In this video, I'm going to talk about solving a system of three equations, which you're probably not used to because most of the time in Algebra 1 and Algebra 2 you solve systems of two equations with two variables. Here we have a system of three equations with three variables. And before we get into using matrices, I just want to do an example out without that so you can see what the process is like. Now, one thing I want to point out is that there is something called triangular form, and I have an example up here on the upper right. Triangular form just means that you have three equations, and the first equation has three variables, the second has just two, and the third has just one. This is a desirable form to be in, because what you'll notice is that, like, since I know, if you look at the bottom line, I know that z is 5, I can plug that right into the top equation there, and that says y minus 2z equals 2. But since I know what z is, I'll be able to figure out y. And then based on that, since I know what y and z are, I can plug them into this one, and I can figure out what x is. So it allows you to sort of work backwards. So that's always a nice form to be in, and that's, in essence, what we're going to try to do here with these equations when we're solving these systems. Now, with a system of two equations and two unknowns, one technique we use is elimination. And in order to do elimination, what you need is opposites. System of three equations and three unknowns, the same thing applies. We want to sort of eliminate one of the variables so that we only have two. That can be done by adding two equations as long as one of the variables can be eliminated. So for instance, let's take equation 1. You'll notice that if you add it to equation 3 rather, this plus z and this minus z will cancel. So let's do that. So when I add them together, I get x plus 2x is a 3x. And I get negative 2y plus a negative 2y is a negative 4y. And then I add 7 plus a 3, and I get a 10. Alright, so that didn't eliminate all the variables, but it did eliminate one, which is helpful. Now, let's add, for instance, the second equation to the third, because that plus z and that minus z will cancel. So 3x plus 2x is a 5x. Negative 5y plus a negative 2y is a negative 7y. The z's cancel, and then 14 plus 3 is 17. And so our lives are a little bit better now, because now I have a system of two equations and two unknowns, which we've dealt with, right? I kind of just simplified this problem one level down. So how do I solve this? Well, again, I need opposites. So let's make the x's opposites. So I'm going to multiply this top equation by a negative 5, and I'll multiply the bottom by a 3 so that I get my opposites. And so now this turns into negative 15x plus 20y equals negative 50. And then I get 15x minus 21y is equal to 51. And this is a great position to be in, because now if I add those equations, the x's will eliminate. So those eliminate, and now I get 20y plus a negative 21y is a negative 1y. Negative 1y, and then that equals 1, which means that y equals negative 1. So now I know y, and since I know y, I can find x by plugging it back into any of these equations back here, the originals. Let's plug it right in here. So now I've got 3x minus 4 times negative 1 is equal to 10, which means 3x plus 4 is equal to 10, which means that 3x is equal to 6, which means that x is equal to 2. And now that I know x and y, I can plug both of those into any of the original ones I started with. So let's just do it to the bottom one here. So I'm going to plug y in there, and x in there, and I'm going to get, so I'll do that all down here, I'm going to get 2 times 2 minus 2 times negative 1 minus z equals 3. So this is 4 plus 2 minus z equals 3, which means 6 minus z equals 3, which means that negative, well, z equals 3, clearly. Alright, so there's using elimination with a system of 3 equations and 3 unknowns. It's the same process, it's just you kind of have this, you kind of have to knock it down a level to this one here, and then you solve that one, and then you just got to backtrack. Alright, so we're going to do this a different way when we use matrices, but I did want to show you that the tools you have at your disposal can apply in this context as well.